Electronic devices contain a whole bunch of elements, particularly metals and heavier elements to make them easy and fun to use. One of these elements that help to make a phone screen pop is lanthanum. As the 57th element on the periodic table, lanthanum is a rare earth metal. Now, where does lanthanum come from and how did it come into existence? Inside an atom is a nucleus, a cluster made up of particles called protons and neutrons that make each element and atom unique. When atoms fuse with one another, or when loose neutrons crash into it, an element can transform into a new element. Lanthanum, and many other elements, are formed from these transformations inside colliding neutron stars or near small dying stars. Neutron stars are dense remnants of exploded once massive stars, and a collision with two of these is powerful enough to make new elements. Similarly, bursts of particles from dying stars have enough energy for more protons and neutrons to stick together and turn into heavier elements. For the elements on Earth, these interstellar events happened billions of years ago. So how did lanthanum end up in the rocky crust? Let's go back in time to the birth of the solar system. About 5 billion years ago, a swirling cloud of gases and stardust, or nebula, collapsed, likely disturbed by shock waves of a nearby star explosion. As the gases and dust moved toward the center, most of them came together as the early sun, while the rest gathered into planets, with those mainly made of metals closer to the sun. 4.6 billion years ago, one of these metal planets became the Earth. A dense, molten ball of iron and nickel became the core, while everything else, including lanthanum, stayed in the mantle, a layer outside the core. The outermost layer, the crust, was made by parts of the mantle melting and cooling into different minerals near the surface. Minerals are crystalline solids that make up rocks. Inside minerals, different elements are arranged together in particular structures based on their size and atomic characteristics. Some elements, like lanthanum, usually don't fit well into the structures of the Earth's mantle, so the rock they are in melts more easily, rising through the crust as magma before cooling into a new kind of rock, called igneous rock. This preference toward magma melts led to more lanthanum existing closer to the Earth's surface in the upper crust compared to the lower crust. However, even though there's more lanthanum accessible to humans at the surface than deep inside the Earth, it is scattered in bits of minerals. Two minerals that often contain lanthanum are bastnäsite and monazite. Bastnäsite is mainly found in carbonatite, a type of igneous rock, while monazite is sprinkled into many different igneous rocks. The largest known bastnäsite deposits are located in China, at Bayan Obo, and in the US at Mountain Pass, though rare earth mining is primarily in China. In order to get lanthanum and other rare earths out of the rock deposits, bastnäsite ore is dug out of open pit or underground mines. To get the purified elements out of the ore, the rock undergoes multiple steps of extraction and refining. In the first step, beneficiation, the rock is physically ground and crushed, and the mineral is sifted by weight or skimmed off a frothy bath. In the next step, bastnäsite concentrate is roasted, lanthanum is leached out with acid, lanthanum salts are chemically removed, or a combination of these methods. Then to produce the final metal, lanthanum can be chemically separated and reacted. The overall extraction process for new metals is typically chemical and energy intensive while generating significant waste, some associated with various human rights issues. Most of these issues are due to improper waste management and mining practices that jeopardize the health of surrounding communities. Some examples include dust and radioactive pollution due to land and waterways, overworked and underpaid labor, and improper practices that trigger landslides. However, if more rare earths are recycled, some of these impacts can be averted. All of those activities, from mining to refining, are part of the journey a rare earth metal takes on its way to a smartphone. When incorporated into a smartphone, lanthanum is used for optical components and sometimes a battery. What makes lanthanum special for optical applications are its abilities to cleanly bend and absorb a unique spectrum of light, as well as its UV, thermal shock, and corrosion resistances. These make resulting screens and camera lenses more vibrant, focused, and durable. From starbursts in space to magma in the Earth's crust to mineral in a refinery and finally to a phone in your hand, lanthanum now helps to bring out color in modern technology before it is someday recycled and used again.